Hey everybody, this is Larry. This is day 22 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. The contest for me anyway right now, as of the recording, is in 2 hours. Hopefully this is a good practice. I'm a little bit rusty, a little bit tired to be honest, though I did sleep enough yesterday, so hopefully this is good. Okay, today's farm is 647 Palindromic Substrings. So given string S, return the number of palindromic substrings in it. A string is a palindrome when it reads the same backwards and forward. Okay. So I'm just trying to think about there are a couple of things you can do about this one, right? If you do it very naively, well, you know, there are n choose two number of substrings in general, subsequence or whatever, in general, and then if you check of them, each of them, you know, in a linear time, that's going to be O of n, right? For each time, and therefore it's going to be O of cube in total, which is going to be too slow. That said, this one isn't. I don't know if you could consider it dynamic programming per se, but you can kind of think about it in a more precise way into structure how to build from bigger components from smaller components, right? And in that sense, it is kind of similar to dynamic programming. And the idea here is that, well, a big palindrome is made out of smaller palindromes, right? For example, if you just have you know, you just have A, B, C, D, E, D, C, B, A. Well, the idea is that there are 5 palindromes here at least, right? Well, 5 that we care about for now. We'll talk about it in a sec. Which is that one is, well, obviously the entire string is a palindrome, but it also means that the sub, you know, B, you know, this is also a palindrome. So this is a palindrome and this is a palindrome, right? So then the idea about a big palindrome is that it builds on smaller palindromes. And from that, I think it should be enough to construct a way to count all the palindromes, just building it slowly one piece by one piece. And in this case, it's going to be n squared. And we'll see in a sec how that works exactly, but it's just basically brute force, right? Is that, okay, you start with this character in the middle, and then now you see if you can go extend bigger, and then keep on extending until you know, you see the palindrome, right? And in the worst case, this is going to be n squared, right? Because for each one, excuse me, wow, I don't know, I'm really tired still, maybe. But basically, for each character, it can be the middle of a palindrome once, and then at worst, it goes the entire way, which is n squared. Of course, there's some nuance here between odd length palindrome and even length palindrome, but that's just checking for extra things. So I think we should be good here. So let's get started, and I think we should be able to kind of just build it out, right? So total is equal to 0, return total. So then now that, I mean, you can definitely do them in one for loop or one set of for loops. I'm going to do it separately just so that it's a little bit easier to read. So yeah. So odd length palindromes, right? Then what does that mean, right? So that means for, let's say left is, let's say n is equal to the length of s. And for, basically, for each one, this is the, so for this, each one, you know, you have one length palindrome, then when you expand, it's going to be 3, then 5, then 7, then 9, and so forth, right? That's basically the idea. While s of left is equal to s of right, here, then we expand, we move left to the left and right to the right. And of course, we should just check that left is greater than equal to 0 and right is less than n, right? And that's pretty much it. Of course, we have to, you know, increment by 1, and that's all you need for the odd number ones. And then now we do even length palindromes. Did I spell it wrong on the last one? I did. dependent. Wow, that D really got far away. But yeah, same idea. So for left in range of n, right, then right is equal to left plus 1, right? Just like the one next to it. And of course, then, maybe this is n minus 1 because, right? And then same idea. And that's pretty much it, really. So this, you can see much clearer that it's going to be n squared, and it should be good enough to go. Let's run it real quick just to make sure we don't have anything silly. Let's see. I think that'll be okay. Otherwise, I don't, like I said, it is n squared, so I don't really worry about with n is equal to 1,000. That's going to be too slow. So let's give it a spin. I did it last year. Hopefully this is right too. Yep. And that's pretty much all I have. Quadratic speed, time, and all of one space, right? We don't really do anything other than keeping track of variables. But if you kind of structure it this way and just expand it out, then that's okay, right? And you could kind of build dynamic programming things on top of this to figure out, like for lookups to see if there's a palindrome in the future. But yeah, but that's pretty much it. I'm also wondering if you can use manager's algorithm for this, but like maybe some kind of modification, but maybe not. Maybe this is fine. Oh, wait, this is my code for last time? Wow. Okay, so I did it with one loop. Apparently maybe there's an upsolve, but for the longest anyway. I don't know that algorithm that well, to be honest, to know whether that can be used to solve this particular one. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.